All right, in 5, 4, 3. And here we go again with another lesson. All right, it's time for, which chapter are we on? 11? 11. Yes, all right. 11-1 today. This is your introduction to the second derivative test. I should come running in and go.
You can't see him.
Okay. All right. Actually, let's go back to the last sample test, which you can see right here. You recognize this from the last sample test.
Are you the track coach?
Yeah.
Okay. Here's the pictures.
Oh, pictures.
Oh.
One moment, please.
I'll hold it up to the camera.
Didn't like 3 people show up because the scheduling got mixed up?
I think so. Let's see. It's more than 3. Not too bad. 4.
I was up top right there. 4 8 and 3.
So let's do this problem right here. Let's talk about it. Okay. Number 13 on the sample test that we just talked about the other day, as a matter of fact. Now, what do you remember about a cube and then you toss in a square?
Camel.
Okay, you get that nice little snake with a bend. All right, so you get this thing right here, right? Now, remember to do the minimum. If you do the minimum of, we're on the air here. If we do the minimum of the derivative, you have to go to the second, right? So we went all the way to the second, and then we got -3, put it on the test, all right? Now, do you remember what the second derivative test tells you about the first derivative? What does the second derivative test tell you about the first derivative? Okay. It's a minimum. What about these little symbols right here?
Tells you the slope.
That would be where the first derivative is increasing, decreasing, because we're only one derivative beyond.
Which tells you where
Right?
It transfers.
original equation.
Well, it'll have something to do with that. It's like Inception. But, okay. So, what does y prime look like? Okay, you don't have to write down anything for this, just kind of watch it. Okay, what does y prime look like when you graph it? That is a parabola. That is, what kind of concavity? I gave up.
Up
Right?
10.
Okay. And then, yeah, shifted. Very good. So, that minus and plus tells you that this parabola is doing what and then what? Decreasing, increasing. Can you see the parabola? Decrease, increase? Okay, so remember the double derivative test tells you where the first derivative is decreasing or where the first derivative is increasing. Okay?
Or both.
And that's the only time we've ever seen a second derivative number line, ever. In the first couple of sections of this chapter, we're going to talk about the double derivative test, which is that right there. But there's something else it tells you. Right? So it's not just about y prime. It also tells you something about the original snake y. Right? Does anybody think they see anything that is negative at first and then positive?
Yeah.
What would that refer to? It's not the slope, it's not the increase, decrease, because this would be plus minus
Point
plus.
of concavity.
Okay, concavity.
Do we honestly say that at the same time?
All right, you get the last one. I'll get
Yes,
this
I
one.
should get this one.
That was quite, and Stephanie, you're right. Quite impressive.
Thank you.
Concavity.
I
Concavity.
think
You
the
good there,
camera
bro?
showed it. I heard 3 beeps.
Oh my gosh.
Still going?
It's still rolling.
Okay, still rolling. All right. Anyway, very impressive if you said concavity. So does everybody see that this snake is concave down?
Yeah.
See that? Until you get to this little midpoint between the two, the peak and valley, then it's concave up. So it turns out that the second derivative test doesn't just tell you the first derivative increase decrease. It also tells you original functions concavity. And we'll use it for that specifically in this chapter. So y is concave down. And if it's positive, y is concave up. And then -3 tells you the changeover right in the middle. Think about that. Pretty cool. All right, so based on that, let's take a look at today's notes.
Okay.
We're going to do that same thing right there. Okay, so the very first one. Perform a first and second derivative test, and let's see what it
Before
tells
you
us.
do?
Well, actually, yeah, that's part of the buzzword. If you can work ahead and kind of figure out what it is, since we've done both of these already, essentially.
You'll beat me.
Right, lazy?
Wow.
Do we get plus 10
You'll
for
beat
that?
me.
Lazy kids? Yeah, it's just, it helps. If you work a step ahead of the teacher and then you check out what they're doing, it matches, I tell you, faster. Yes, you don't all have to be Mr. Wade.
What was that?
That's what I did when I was in high school. Anyways,
Well, either
okay.
that or we'll mess up and then have to erase
Sure,
the
of
whole
course.
page.
Done.
We've already done first derivative test. You can do that,
Done.
right? Thank you, Katie, right. Oh. Okay.
Good distraction.
All right. Now, I can assure you that the first step is not that arduous
It's hard.
for you lazy butts.
What's that word mean?
All right?
Hard.
Hard.
Yes, it's not too difficult, okay? All you had to do is take the first derivative factor before I got to it on the board and then make a first derivative test. I know some of you work ahead already because I've seen you in class. You work a step ahead. You're like, already got it?
I
Okay,
already
see, I like
finished
it. And then you sit back and you're like, oh, got it. You tweak that right there. It works? Okay. All right.
Are you using KGB?
And then some of you are, okay, 2 times 2 is, and you wait for me, and you wait for me. 2 times 2 is. Some of you just wait. Some of you wait till I write down every number.
Who's
All
looking
right.
at me?
Yeah,
I'm
you
done.
can think that. Okay, good. All right. Now, first derivative. Okay, did anybody get x squared minus
I did 4x.
4x minus
4x
21.
minus 21? Okay. When you take a derivative, what's the first thing we usually do?
Set it equals 0.
Set it equals 0. Try to find your critical numbers, all right?
Yeah, it's gonna be 7 negative 3.
Matter of fact, this does factor nicely, doesn't
Why'd
it?
we factor it?
It factors into -7, positive 3. Okay. All right, so the critical numbers are actually going to be the opposite.
7 and negative 3.
So 7, negative 3, so the smaller one's going to go down here. So that's negative 3. And then the bigger one, 7 goes up there, and let's label it as y prime. Okay, and you remember last test, you plug in some sample points, okay? And what should you get, if you want me to I can just skip the actual plug-in sample points, that's easy, but what should you get if y prime describes the increase, decrease of the original function? Let's see, the original function, x cubed, there's an x squared in there. Oh, you know what it is, isn't it? So if the original function is snake with a bend and you plug in your sample points, what should you get?
Parabola.
Should get, but what?
Positive.
Positive, negative, positive, because the original function is going up, down, up, right? So you definitely will get a plus, minus, plus. Okay? Now, usually I would advise for you to plug in your sample points to make sure you verify that this is correct. But if you know it's a snake with a bend, you do know this is going to happen. Okay? So we'll save some time. So that's that. Now, the second derivative test. To do the second derivative test, all you have to do is go to the second derivative, and that would be
2 minus 2.
2x minus 4. And guess what we do? The same thing you did in the first derivative test. You set it equal to 0. Now, actually, for the second derivative test, they're not called critical numbers. They don't really have a name. But you're basically finding the neutral places again. Okay? So, let's solve this one. That's going to be x equals
Negative 2.
positive 2. Label your number line, y double prime. And do a second derivative test. It's the same as the first derivative test. You just pick sample points. The only difference is it means something different. Okay? Like the original function. So, pick some numbers like 0. If you plug in 0, what do we get right here? Okay, negative. Or pick 1,000, what do we get? Positive.
No way.
So that tells you two things. That tells you that the first derivative parabola is doing what and what? Decrease, increase. Wouldn't that match a parabola? And it also tells you that the original snake with the bend is
Concave down.
concave down, and then it switches to concave up. There you go. So 2 different meanings. Okay?
So
And that's about all the second derivative tests will ever tell you, those 2 things right
So could you technically tack on the second derivative test to the first one, like connect the lines?
there. You could, yeah, and get a really accurate graph,
Yeah.
actually. Yeah, we'll kind of do that today, actually. So, yeah, kind of put them both together. All right, so there's your second. So making a second derivative test is very easy, and actually, do you notice that the more derivatives you take, the lower the highest power is? Because we started with a 3rd degree, now we got a 2nd degree, now that's just a 1st degree. That just graphs a line when you graph it right there. Take the derivative with that, then it's just a number, then it's just 0, and then 0, and then 0, and just disintegrates. So it gets easier the farther down you are.
What are the big boxes for?
The big box, okay, let's do that actually right now.
Oh.
In the big boxes, let's do a little sketch here. All right, first of all, we know what y looks like. No. Y is the one that is a
Camel.
snake with a bend. kind of like that. Okay, now let's mark some important points in there. Not the actual numbers, but just important places. What are some important places on a snake with a bend?
Minimum maximum.
Sure, very good idea. Let's mark that little peak. What's the mathematical term for a peak?
Extrema.
Okay, the extrema, and this one would be a relative or an absolute?
Relative.
Yeah, because it's not the absolute highest, but it's relatively in that area the highest. So this would be called a relative what? Okay, or specifically, yeah, specifically a maximum, right? So relative maximum, and then a valley in professional math terms would be called relative minimum. It's not the absolute, but it's a relative, okay? And then there's this place in between that is the midpoint here. If you average those on a straight segment. Okay? And that has a name as well. Matter of fact, we did it in the first semester like once or twice. Haven't talked about it too often. But it's the place where this concavity suddenly
Symmetry.
changes. Okay? What is that place called? In
Fusion.
yeah, not the infusion point. No, I thought it was. Well, that's closer.
She said.
In, yeah, did you say inflection point?
Yeah.
Yeah. Who said that first?
You did.
That was Abby?
Anna said transgression.
Inflection point is correct. Abby Durek, guess what? Or Stephanie Durek. That's plus 10. Very nice. We're so close. All right, so
To the board.
that is, no, hey, now that's not nice. Okay, that is an inflection point. So, now there's not enough room to write an inflection point. Let's just label it an IP, that'll stand for inflection point. So the inflection point is where the bend changes. So like, if you're on a roller coaster and all the cars are compacted this way, suddenly there's that point where they compact the other way, right? So the angle